So welcome to the type 4 of probability. Once again, this is Seyon Busy Made It Easy channel. So the type 4 probability involves the addition and multiplication of probability questions. Now, how do we add or multiply probability questions? Now we add when the question you hear and maybe a fair coin is thrown once. What's the probability of obtaining a head and a tail? So head and tail at the same time. Probability of obtaining a head is 1 out of 2. Probability of obtaining a tail is 1 out of 2. Now, so when we ask this question together, what do we do? So when we hear and, we multiply the two events. Or what's the probability of obtaining a head or a tail together? So this one, 1 on 2, this one we add. So when they ask you events involving or and end, when we hear and, we multiply the two events, and or we add the two events to get our answer. As simple as that. Yes, especially when there are two different events. With a type 3, they said the head and tail. That one we are performing them together. But this one you can see there are two different events that they are asking you to find the probability of one and the other. So take note, when you hear and, we multiply the events, and when you hear or, we add them. So this is when we multiply or add. So we are going to take our first question on this type. Now the first question says that a bag contains 5 red balls. So we have 5 red balls, then 4 blue balls, then 3 green balls. A, find the probability of selecting a red or blue ball. A red or blue ball. And the B says find the probability of selecting a red and a green ball. So A says probability of obtaining a red or blue ball. A red or blue ball. First of all, you have to know the total outcome. The total outcome, we add the balls. So 5 plus 4, 9, plus 3 to give us 12. Now, the question says a red or blue ball. So we are using the or, it means we are going to what? Add them. But you have to know the probability of obtaining a red ball. So probability of obtaining a red ball is going to be 5 out of 12. Then probability of obtaining blue ball. Of blue ball is also going to be 4 on 12, for which will give us 1 on 3. I didn't simplify this because we can't simplify it. So you have to know the probability of a red ball, probability of blue ball. And now, before we come to the probability of a red or blue ball. Now, I told you earlier that when you see or, what do? We add them. So probability of obtaining a red ball is 5 on 12 plus. You can use the 1 on 3 or the 4 on 12. You can get it. You get the same answer. So addition of fractions. Now the LCM here is going to be 12. 12 will divide 12, 1 times 5, 5. 3 will divide 12, 4, 4, 1, 4. So you are going to get 9 on 12. For which when you simplify, use 3. So we get 3 out of 4. So probability of obtaining a red or a blue ball is going to be 3 out of 4. It's going to be 3 out of 4. The reason why I said when you use the 4 on 12, you get the same answer as when you have 5 on 12 as the probability of red ball, adding to the blue ball 4 on 12, the LCM will still give you 12. 12 divide 12, 1, here 5, 1, here 4. You still get 9 on 12, which will give you the 3 on 4. So don't be confused here. So this one I simplified it, so you get the same answer. So we use the or and we have added it. So we are going to take the question B on this. So the B says probability of selecting a red and green ball. Red and green ball. So we have to know the probability of picking red ball. So red ball, 5 on 12. Then green ball. So green ball is 3 on 12. Yes. And I said probability of a red and green ball. Now, how do we do it? Now, they are saying and. Let me make it capital. So, and. The other one was or, so we added. So, this one is and. So, we are going to multiply. So, we have 5 on 12 times 3 on 12. So, this one will give us 15 on this times this will give us 144. So probability of picking a red and a green ball. A red and a green ball, 5 times 3, then 12 times 12, which will give us 15 on 144. We can divide here 5, then divide 1. We should always simplify this. Or we can also have 5 on 12 times the same 3 on 4. Division of fraction, we can cross divide. 3 divide here 1, divide here 4. So we have 5 times 1 over 4 times 12, which can also give us 5 on 48. So whichever way you do it, you can also get your answer in the simplified form. It's very, very important, especially when you're dealing with probability. It's good to simplify. So this brings us to the end of the question 2. Question 2 on this question. Question 1b, sorry, on the or and the and question. Let's take another question on this. So the question 2 says a die is thrown once. Find the probability of getting a number that is even or greater than 4. Even or a number greater than 4. A die, our sample space. 1, 2, 3, 4, 5, 6. So we have to list our sample space, which is very, very important. So the A says probability of obtaining even number or a number greater than 4. So the or is here again. So first of all, we have to know probability of obtaining even numbers on the die. So even numbers, we have 1, 2, 3. So we have 3 on 6, which will give us 1 on 2. Then probability of obtaining a number greater than 4. That one will be 5 and 6. So which is 2 out of 6, which also give us 1 on 3. So now we have seen the probability of even numbers, the probability of a number greater than 4. So therefore, probability of a number or of an even number or a number greater than 4. Now, or is here, and I said that or we add. So probability of even number, we got 1 on 2 plus greater than 4 or a number greater than 4. So we add. So the LCM here is going to be 6. 2 divide here 3, 3, 1. 3 will divide here 2, 2, 1, 2. So we get 5 on 6. So the probability of obtaining an even number or a number greater than 4 when a die is thrown once is this is how it is done. So or means we add. Now the B, question 2b says that find the probability of a number that is even number and a number greater than 4. So we have to know the probability of even numbers. And we have done it already. Even numbers, we have 2, 4, and 6. So we have 3 on 6, which is 1 on 2. Then probability of a number greater than 4. That one too, we have done it. We got 2 on 6, for which we simplify to get 1 on 3. So now probability of even number or a number greater than 4, or we added. So, or we added. So, and, sorry, this one is and. So, and what do we do? We multiply. So, an even number, 1 on 2 times 1 on 3. So, and we multiply. So, 1 times 3, 1 times 1 give us 1, 2 times 3 give us 6. So, probability of obtaining even number or greater than 4, we add it. Probability of obtaining an even number and the number greater than 4, we multiply. So, this is how the question 2 is solved. So, let's take the last question on this series. So, the third question is, there are 10 beads in a bag. 5 beads are black. You have 5 black beads, then 3 white, and they say the rest are red. The rest are red. So a bead is picked at random. Find the probability that it will be I white, I black or red, I not white, and I not blue. Yes. Now, before we add the sample space, they say the red. So we have to know the red beads. So the red beads will be 10 minus 5 plus 3, which will give us 10 minus 8, which will give us 2. So the red beads are 2. Yes, here they've given us the total bead, which is 10. So we have to find the red beads before we can proceed with our question. So the I says that probability of picking a white bead. So white bead will be number of white beads over the total beads. So how many white beads were there? 3. The total beads are 10. You can't simplify this. So this is the probability of obtaining a white bead. Now probability of obtaining black or red bead. Black or red bead. Now, in our previous question, I've told you that when we see or, it means we add. So what will be the probability of obtaining a black bead? That one will give us 5 on 10. Plus probability of obtaining a red bead. The red bead will give us 3 on 10. So 2 on 10. The red bead is 2 on 10. So we add. So the LCM will be 10. 10 will divide here. 1 times 5 is 5. 10 will divide here. 1, 2. So we get 7 on 10. So probability of obtaining a black or red bead. Or we add. So you have to know the probability of each of the questions given, then you add them. So we can't simplify this. So that is how this question is solved. So the probability of not picking a white bead, which means you are looking at if it is not white, then it means we can pick any of the other beads. So it is either the black bead or the red bead. So probability of picking a black bead, 5 on 10, plus probability of picking a white bead, not white, sorry, probability of picking a red bead, which is 2 on 10. So probability of not picking a white bead means you can pick either black bead or the red bead. So for which this one too, the LCM will be 10. Here will give us 5, then 2, then we get 7 on 10. So it is like this, black or red bead. So if you pick any of them, so it's the same answer. So this is it. Then the red bead, probability of not picking a black bead. Not picking a black bead, you can pick either the white or the red bead. So the white bead, 3 on 10. And the red bead, which is 2 on 10. So 10 here, then we have 3, 2. So we have 5 on 10, which will simplify as 1 on 2. So probability of not black. So not black means we can pick a blue bead or a red bead. So probability of not black means we can pick a white bead or red bead. That's why the or we normally add it. So when we simplify, this is what we get for the question 3. So this brings us to the end of this type. So watch out for the last lesson on probability, which involves 2 independent or 1 dependent and 1 independent component of probability. Don't forget to subscribe to this channel. Recommend to everyone to have a benefit of it. Until we meet again, we say goodbye and see you in the next lesson.